Hello everyone. I hope you are doing well. Hello, hello, hello. I know you are be surprised with that there is no problem today and you directly came with some solution. Oh, and it looks familiar as well. I hope you know this problem as well. What will you talk about this in the video? I hope you read the title. I will be discussing today that most people face this problem that yeah, I can write the recursion plus DP, no problem with that because it's very intuitive. They hate recursion. Surprisingly, they hate recursion, but when it comes to DP, they will use always recursion. They won't use a for loop method. But when they have to write a recursive solution, they will say no, for loops are good. Why to use recursion? Right. So this is a very good dilemma that every person have. And don't worry, if you're not alone, I myself face this problem. How to overcome this? We'll try to discuss and also with the help of an example that how to change your mindset and why it is important. Let's try to discuss first that thing and then I will come to this problem. Let's try to discuss that why you should learn tabulation. You should learn tabulation. Tabulation DP. That's your main agenda. That people are unable to write from recursive to tabulation or directly how to write tabulation code. Bhaiya, we are not able to understand. So, firstly, let's try to understand why you are not able to write it. Why it is difficult. It seems difficult. It is not. The reason is you don't know what exactly the DP table is signify. What exactly? Tell me. With the help of example only, I will ask you. DP table is signifying signify signify what is implying, okay, means what is imply okay, imply. Now you tell me what does this DP of I comma target tells you. Tell me in the comments if you know the answer. If you don't worry, we'll try to understand it. What does it mean? Look, people know, oh, it's a simple, right? I need to make target. I have two options, pick, no pick. They just memorized it. Oh, you can pick this, you can not pick this. And yeah, you can solve I plus 1 minus the target. Don't do the target, remove that. And it's fine, no problem. But is it the case when you will understand, okay, what does exactly this DP of I comma I? What? Oh, states. How do I make states? It's very simple. Index to always will be there. What target I have to make? That's why I made target. I don't know what this DP of I target signifies. Important thing is you should understand that when you are making a DP, what this signifies, then only you can write this transition. Right? It will be very useful when you are writing a tabulation DP. It is signifying till ith index till ith index, can you make the sum target? Can you make the sum target? That's your prime question is very important. Okay, firstly let's try to understand that and then you write the transitions from here. Transitions here, this is the way, correct way to learn the DP. It's not like that, oh, I learned some, memorize some patterns and then I will apply on every problem. Some problems, yeah, will won't be. Some problems require optimization. Some problems requires, which is advanced DP problems, which may come into OA, require, or maybe in code forces question require optimization. Let's say some prefix. You must have solved some questions in which some prefix of DP have comes. You cannot apply on recursion DP. You cannot apply. You cannot do this on recursion DP. It's very important that why you have to learn it. That's also very important, and how to learn it. We also will see that. So, firstly, the first step is right now. From every time you solve a DP problem, always write the state. Whatever, if you're solving with recursion, also write the its states. Okay, what it is signifying, why I made this state, and how it is changing the things. Right. Firstly, this and try to write transitions from here. Okay, from in terms of I or whatever you want to do. So what would be the transitions from here? So let's say I want to write this tabulation code. So see, you should understand the concept of bottom up and top down approach as well, right? What is bottom up? What is top down approach? Okay, what you are essentially doing, you're going ahead here, I plus one. What you generally do in tabulation, you can go in both ways. I'm going from front, okay, but top down. So what you're going to do is, I will run a for loop, try to understand how I am writing the 0 I less than n. It's very simple, it's very simple. How to write a tabulation DP? It's very simple, right? Let's try to understand. Firstly, you have to define the base cases. That what base case you have to do. But let me just write for you the in terms of, let's say, target only. Uh, yeah. So let me just do the help of target only. Okay. Initial target is, let's say, k. You want to make a sum of k. Okay. Let's say I initialize a target with 0, and let's say our target goes to, let's say, k. I want to make it till k. Target plus plus. Now let's try to understand, okay, how to write the transitions. Okay, I hope you know how to write a particular transition. The problem is subset sum equals to k. Remember that I know you have solved this problem many times in many variations as well. Okay, you have to pick it, you don't have to pick it. Fine. Okay, no problem. So what is base case? See, when you're writing a tabulation DP, right? You cannot write like this, oh, just return something like this. That's the difficult part, right? You have to define your base case. Now start thinking, okay, what is the base case? From this, you will understand a deeper understanding of DP, because if you write the recursive code, right, only recursive code, I know in context you should write, because it's fast, it's not much take time taking. But when you're writing a tabulation DP, right, you will get a very good habit of writing a tabulation DP, and then you will quickly write more fast than recursion. I will explain you how also. Okay, so what do you know? Can the zero sum can be achieved always? You will be like, yeah, yeah, always, no problem. I will not choose to pick any index. That will always be possible. That what does mean? That means that DP of I comma 0 is always possible for each I. This is the base case. Base case. Okay. So what you do? You will run a for loop for, this is the thing you have to write when you are writing. You're gonna go sum from I equals to 0 and I less than equals to n, and let's say I plus plus, and then you wanna gonna do what? DP of I comma whatever 0 is always true. It's a true and false DP. Okay, that's always possible. Subset sum equals to k problem, right? This is how you define it. Obviously, you have to define it above. I'm just writing it below. Yes, I don't have much space. Okay, what are the transition? Try to recall that. Oh, transition, pick and non-pick logic. You apply the same concept here. You are a particular thing. Either you can pick this element or you cannot pick this element. You are at some index nums of I, right? So you are at, let's say, nums of I. You can pick this. You cannot not pick this. Now again, there is a condition on pick. When can you pick this? You can pick this when your target is greater than nums of equals to I. Then only you can pick, right? Otherwise, you cannot pick. Not pick, so you can always do. Always do. Okay, fine. So let's try to visualize from indexes that how to write the transitions. So when you are at from index comma I comma target, so what you can do? How you can get the answers from here? Okay, from previous states. Let's say you are at I minus 1. Okay, you are at I minus 1. Okay, let's try to write this like this. So either the answer comes from I don't pick the current element, then what's my DP of target will be if I don't pick the current element? You will be like, my answer would be DP of I target is equals to DP of I minus 1. If I can pick till the last index, I can make the target. This is fine because this is the not pick logic, right? I just skip the element. Or if I can pick the element, then I have choice of picking it or also not picking it. This is the no pick logic, right? And then you will be like, if I can pick this, that means what? This condition should be satisfied. then I can write dp of I comma target is equals to what? dp of I. You can just do a or. You can either pick it and not pick it, or means you can put a this sign. You can pick the till index and you just reduce the current nums of I. How beautifully you write that, and this is done. This is it, yeah. Nothing else. You have done entire solve. And now, what's your final answer? Now, what's your final answer? Tell me. Tell me what's your final answer? What you're trying to solve? What you're trying to solve? You are trying to solve that till n minus one index. Can you make some target? Can you make some or target sk? Can you do that? And how to return that? They are very simple. What is the solution of this? This is dp of n minus 1. Okay. If you know this state, this dp table, you can easily rewrite these kind of things. You don't need to think much. When you start try to thinking in these kind of things, right, in this way, you will learn a lot about dpo. This is how we can write, right? Now you have a command over all the elements of the dp. You have the entire pre-computed stuff. I also tell you one more thing. When you try to compute recursive dp, right, you will say our dp table, so that's also populated. No worry there. No, you are wrong here. When you do this kind of recursion, right, not all states are computed, not I comma target all pairs are computed. No, you're not, you're wrong here. You can do that, you can do that, you can run a for loop, you can do some stuff, but you cannot be ensured by running this only this thing that okay, the complete dp table will be populated. So that's a major difference as well. Okay, some states will be computed will only based on the k, right? Whatever the states are required to calculate compute dp of ik, only that state would be computed. So that's also a difference that you should write these kind of things. So my motto was firstly tell you what's the importance of the DP, of tabulation DP, how you can approach it. I showed you with the help of example that okay, write the state, understand the state, what the DP is signifying, how to write the transitions, try to write on paper, and then try to run the for loop. Try to write the base case. Okay, what could be the base case? Oh, this is the base case, right? Sum is equal to zero. Try to write in terms of the for loops or whatever you want to do that. Find the final sub problem, what do you want to solve, and then you just return it. If you understand this whole process, then you will able to master dp problems like crazy, and then you can think like hmm, in contests and all. So this was thought was came from many people among you that you commented me that oh, I'm not able to solve lead code contest of or maybe code forces thing that. But yeah, I hope you understood it well. And if you are also, that's why I created an entire unique playlist for you guys for the OA series, which have good DP problem. Initial three problems are good DP problems. You should check it them out. That how to think and construct solution from there. So yeah, and if you're new to the channel, make sure you hit the subscribe button because we make awesome content for you. And also one more thing, one more surprise is coming for you guys on the channel. Stay tuned for the further updates.